An imperfect pipeline is not okay. An imperfect prediction is 100% okay. And the system has to tolerate that wrong prediction. How do you design your system so this is in play?
Sometimes the cost of being wrong is no big deal. Sometimes the cost of being wrong is a really big deal. We need to design the product so that the experience of it being wrong sometimes isn't bad.
Welcome to One Idea. Jason, I have one story to share where the first month before we are starting Sedai, I went with my investor to one of your friends. We had a meeting there and he was one of our early supporters in Sedai. So thanks for that. Now, you're building a system that is layering one important thing on the other important thing. That the first important thing is really an AI layer. And the second one is a deterministic layer. How do you manage this?
First off, thank you for having me on. Excited to be here. And it's fun to find the connections that we have as we go look at our past. When you talk about these different layers about like deterministic data and then some of this like probabilistic stuff with AI and LLMs, to me, I think the biggest part is everyone, especially who's building the product, to understand those abstractions. I actually think it comes down to like just like computer science and engineering in general, software engineering in general, is being disciplined about what is what, right? Like for Laurel, we effectively gather a bunch of data about the activities you're doing, what you're doing. You're on a Zoom call, you're in a document, whatever. And then we do a bunch of AI stuff on top of that to try to understand that. And I think for us, at least for me, the big part of, and try to get everyone to think about this is making sure we're clear, like, hey, this part really needs to be deterministic and always work, right? And it works predictably and works as we expect computers to work. And then this part is the part that's like, hey, this is the more predictive, this is the fuzzy or probabilistic part. And this is where it's super exciting with LLMs. You can be like, okay, hey, actually understand the human fuzziness better. But it's not fuzzy if you are on a Zoom call for 28 minutes. Like that's not fuzzy. That is truth, right?
Right.
And so I think doing that is really important because then effectively how you build product, how you engineer, et cetera, is with those abstractions rather than it being kind of a muddied kind of mix of things, which allows you to do all the right things from like building product the right way of like designing around where your probabilistic thing might do something weird, but also from just an operation standpoint of like, how do you think about, incidents and maintenance and all of that as well. And so I think to me, it's actually, it's mostly about like the abstractions, like getting the abstractions right and like getting everyone to be on the same page on those abstractions.
Now, I think maybe telling a little bit about what you do now would help this clarify some of these questions, right? What is the deterministic layer supposed to do for the product that you're building? And what does a probabilistic system do?
So I'll go quick about what Laurel does. So Laurel, kind of the main product is around helping people who bill for time do it more easily and more effectively. So it's like, think about lawyers and accountants, they bill per hour. Right now, before Laurel, they effectively hand track what they're doing. And so what we do is we first collect data on what they're doing, right? That can be, like I said, like, what, web integration. So what, Zoom call or video conferencing call you're on. But it's also desktop software to be like, oh, you're in this program, working on this document or sending this email, et cetera. So that we have that context. And so that's kind of that first part, the deterministic part. Let's get all this information to be just like the raw information of what you're doing. And then the probabilistic part is, as you might guess, like when you think about your work, you're not like, I spent 10 seconds looking at this window and then I, was on Zoom for whatever. Like that's not actually the most useful way to go figure out what you should build time for. And so that's where we do the probabilistic element of like, okay, hey, we know you're working with these clients. We can help you assign this type of activity to these different work codes to different clients and describe it as like, hey, this is what you were doing. That's all stuff that a human would have done. They would have been like, okay, I was working on this. I have to think about what I was doing and then I got to go write it down and blah, blah, blah. And so it's that mix. It's like the mix with deterministic and probabilistic is like there's a deterministic ground truth, right? There's a ground truth of what you were doing and that is a deterministic part. And there's a bunch of work there. And then there's a probabilistic part of effectively converting it into the human mental model of that work and the human description of that work that then goes out in the bill and whatever else.
Most of these agent failures happen when you mistreat probabilistic behavior or a deterministic behavior, right?
Yes.
And they sometimes treat a probabilistic action as if it was supposed to be correct. How do you handle that?
Yeah, I mean, I think that goes back to like understanding where we bucket and handle those abstractions, right? Is like, so we have that data collection later. We do a bunch of stuff with that. There's some parts we could do probabilistically. I think we try very hard to be like, this data was probabilistic and this data was deterministic, right? Because I think it's really important for exactly that reason. If you have something that you assume was deterministic and you try to build like layers of probabilistic stuff on top of it, it's kind of a tower of cards, right? Where if you know what you're building in each of those steps, I think you can manage it better. And then part of it then is, um, like, as you said, like, it's like, okay, if you treat them in the wrong bucket, you can have issues. And I think that's part of, like, is product design, right? It's like, hey, if you design the product of like, "Hey, we have this data that is truth, and then this experience is probabilistic," and so you can design around, "Okay, hey, we have to know that sometimes it'll be wrong. Even if in the perfect version of this product, sometimes it'll be wrong, and so we need to design the product so that the experience of it being wrong sometimes isn't bad," right? And people don't lose confidence in the tool. People have an easy way to solve it. Like, you don't wanna be wrong and be, like, more work to, like, check and clean it up, right? And so, like, it to me is like that's where you gotta get close with that, and then, like, that's where, like, the whole team, if you understand the what's deterministic, what's probabilistic, and then which parts of the product do you kind of solve the unknowns from the probabilistic part is ends up being key to make it a good overall experience, I think.
Yeah. So a follow up there, right? So if you end up getting a recommendation from a probabilistic system, do you make an attempt to convert it to something that is a lot more deterministic before showing it to the customer? Or do you just tell the customer that, you know what, this is probabilistic, take a look at it and then decide?
I think it depends. I think this is actually where that's it to me, it's like getting so close with the design and getting we actually specifically have, like, some of our AI-focused engineers, like, have weekly cadence with design specifically because I think it's so dependent on what we're predicting and what are we doing, what agent we're doing, whatever it may be, and the performance of that, right? Like how often is it right or wrong, et cetera. And then the big one is like, what's the cost of being wrong, right? Sometimes the cost of being wrong is no big deal. Sometimes the cost of being wrong is a really big deal, right? And so like for example, like one of the things we do is we predict the word description of like this like 12 minutes of your time you were doing this, right? Where we effectively pre-fill a text for you for what it is. I think that's a good example of like one, obviously we want to be as good as possible, but people are generally looking at it before they complete it. And it's also very easy for them to change. It's just a text box and they can go change it, right? And so like that's a good example of like, you know what, like let's just go. Let's just put something in there. You're gonna look at it anyways, because like it's kind of officially the marker of your work. And so like that's like one bucket of like if we're wrong, we handle in one way, right? And then there's others of like we kind of predict we'll like, you know, make a harder connection of like you're working with this client or this more structured thing. And like, all right, we want to make sure that if we go and do this, actually a better example is like we assign this different time you're spending to like you should bill for this, whatever. And that one we want to be a little more careful about because like if we go and do too much of that, you can be like, oh, oops, I like booked time that I wasn't supposed to, and that's gonna create trouble. And so like, all right, we how do we one obviously get the performance up, but then two work with design of like, all right, we expect this to be as accurate in this way, that way, and so let's design the experience around that. And so in this case, like we'll be like, okay, hey, you should like figure out what activities you want to go and bill for, and then we can go make predictions for it rather than the other way around where you feel like you have to clean up. So I think it's so much around like understanding your evals and what your performance looks like, and then like designing your experience that takes into account how the user side of it makes a huge difference for like managing that probabilistic like when it works, when it doesn't work, and it feeling really good at the end of the day.
So the quality of data, right, under it, that's where I think people get at times things wrong, right? The quality of data, how important is it?
I think it's the utmost importance, right? I think it's like, I mean, this has been true forever, right? The garbage in, garbage out type of deal, right? And like that the quality of data is key. And like, I think a big thing with LLMs now too, right, is like a lot of times you're often working just like huge amounts of data too, right? And so like a lot of it is just like making sure you have just good data is a huge part of it. And then the other part of it is in this case, especially for LLMs, is like giving it enough context on like what data is where, et cetera. It's also a funny thing too, because like depending on what you do, is like you definitely can give too much data to the LLMs too. So I think it's you want to have good quality data, and then you got to do the work to like figure out the right pieces of data or whatever else. But yeah, that data in is key.
Do you think LLMs will ever get to a place where it's always giving the perfect answer?
I'm not enough of an expert on LLMs to say that for sure, but I would doubt it. And I say that because like at the end of the like I would doubt they would ever always give a perfect answer. And I think part of it is just because it's not possible because part of it is as humans and everybody, we're imperfect about providing the full information, right? Like part of like actually I tell like unrelated to LLMs. There's in building software in general, right? Like you always have a thing of like you want to be careful to not go build a huge project for like 2 years and like I'm gonna just do a 2-year project on a big thing. I'll get back to the point at some point here. Um, and you don't want to do that. And it's not because that you're a bad engineer, you're not going to do a good job software architecture. It could be, but that's not to me. Actually, that's the big reason. Is that you actually don't know where you will need to build over that 2 year time frame. Like it'll change. Like you'll get more information during that time frame, and that you'll go figure that out. And I think there's similarities here with AI. It's like you can ask a question to AI, it can give you an answer to that question. Maybe get better and better on answering that question. But what it doesn't know is what is the full context of why you're asking the question, your life history, all the other stuff that like will be a perfect answer to that question, right? And I think that's the same thing with humans. Like if you have a one-off question, like you don't have all the you need just more context to do that, right? And so like I think it's almost like it's an impossible problem. And so then like it's never gonna happen and it's not a reasonable goal.
Exactly. So this is how I generally look at it, right? So to answer anything that you ask, anything, right? Could be LLM, could be a system. Fundamentally, there are two processes in play. You understand the question, then you answer. LLMs don't understand your question, and it's not designed to understand your question. It's for the same reason I don't think it'll ever get to the right answer. So I think the problem in my mind is generally people think it understands an answer. It's deceptively like large that almost anything can be answered closer, and you think it's going to get better. To get better, it has to first understand. So fundamentally, it doesn't understand. So there is no opportunity for it to get to 100% ever. When I make this claim, I know that a lot of people might say, you know what? No, you're wrong. Unless you change the fundamentals behind it, or a chip comes out that can do something different, I think this is going to hold true. Is my take generally.
Well, I think part of the thing that's really fascinating about it is like I think we all ChatGPT really help with this is like we kind of think of LLMs as like on the kind of like a person in their spot,
Yes.
right? But
Yes.
the funny thing is with LLMs, the order in which they've learned things is different, right? They're amazing at constructing language, right? So they're like an adult, a sophisticated adult and be able to create language, but that's not how their reasoning got to, right? They're like they're not like they're obviously much more impressive now. And there's been a lot of work, but like early days, it was like a very, very small child and logic, but they spoke like a very intelligent adult, right? And I think that that's part of the trick is like, oh, you sound so intelligent, and like that's as humans, that's our proxy often. Like, oh, hey, you sound intelligent, well thought. And like, okay, you know what you're doing. Where LLMs is kind of funny because it's like effectively they could turn on a like I know what I'm talking about lens without knowing where humans are different. And so I have young kids, and like I think about this sometimes. So I was dropping my kids off at summer camp this morning, and he was like, "Why is that like that?" I'm like, What are we talking about? What do you mean?" Right? But like, I think that's a good example of the like as you were talking, I was thinking about that. It's like it's the context that he had in his brain that he wasn't expressing correctly to me, so that I couldn't know what he means, and so I couldn't give him a useful answer. I almost think that there's parallels here, right? And like, obviously, as an adult, you get better at like asking good questions, but still, there's still missing context, missing understanding, missing whatever, right? And like we're just saying here, is like with kids, you kind of human kids, you see that development over time because you're like, I'm not in your brain, kid. You gotta give me something here. Where LLMs, it's so different in how you interact and how it feels, and so like it seems one way, but it's not that.
Multiple times you have mentioned that an imperfect pipeline is not okay, right? An imperfect prediction is 100% okay. And the system has to tolerate that wrong prediction. How do you design your system so this is in play?
I think that goes to how we monitor and how we look at a lot of this stuff, right? Like anything that is in that deterministic standpoint, like honestly, we treat it like we did 5 years ago of like, hey, this needs to work, and we're all the things that we expected at a certain quality. While all the probabilistic stuff, like it's honestly a huge mix, right? We effectively applying a bunch of different tools to that, right? One is some amount of some amount of performance metrics where we can of like if there's a users like some of the examples I gave before of like if the text that they're writing that we're writing for them are people accepting it at the same rate as they were before, or is there some change, etc. We're like watching for those signals, or and also obviously we did offline evaluations against sets we have, does it work as we expected, etc. And so there's just a lot of different tools I would say we apply to it to keep an eye on it there. um and there's also just like human time spent on that one, and the way that one is like the way I kinda describe it with the team, we've talked about it is, we as a team, we're trying to build these, like, deterministic evals and monitoring of user activity, um, and they're all just proxies for, like, the user feel like it worked, honestly, at the end of the day, right? And so like we'll do internal evals that we can test at any time. And so we do that. The next layer up is like this product metric side of like, hey, are they interacting with a way that implies that they seemed it was good? And like, how does that, what's the healthiness of that? But then the last one is like, just like we try to spend time with users like, hey, validate that our proxy measures are mapping to like what you feel, right? And so that's the qualitative last bit of like, okay, cool. We can keep operating against these hard metrics because these hard metrics are actually indicating what we really want. And so like we try to do that, right? Is like try to layer on obviously a bunch of quantitative, structured, deterministic like measures of this probabilistic product, and then validate that it's like actually mapping to what we want.
This is a philosophy that you developed with three companies at the very least, right? So Relate IQ, then Ironclad, and now Laurel. All these three places, I'm thinking you probably looked at your monitoring methodology, you looked at your incident response, and you made sure that the incident is responding differently to a deterministic system failure versus a probabilistic system failure, right? Is it a culture thing? Is it really process in place, or is it things that you do?
I think there's huge culture parts of it, right? Like I would say there's a base culture of like, hey, making sure everyone understands like the customer, what we're trying to do at an organization, et cetera, right? And so therefore being able to internalize this like, hey, for certain kind of failures, we have certain responses effectively. And then there's the process side of like, once again, like for certain kind of failures, like deterministic ones, like, all right, we need to respond in this way because we expect X, Y, Z. Effectively, what is the contract that the rest of the product expects from this deterministic side of it. And then for the probabilistic side, what does that do? How do we route that? Oftentimes, actually, a lot of the probabilistic stuff, that one ends up routing to a sub team most of the time, right? Is the team that kind of lives in that world. As a tangent, I think that this is gonna be a really fascinating thing for the industry is like we have always for software engineering for so long, I've always kind of described it as easy in the sense that like it's deterministic, it's very logical. 1 + 1 is always equal to the system. You can pretty much derive any system that's out there because like, oh, some smart other human came up with it, right? So like you should be able to figure it out. And if there's any time it doesn't work, there's a bug. Someone did a bug somewhere. Like it could be a very hard bug, but there was a bug. Now with the probabilistic stuff, that's not true, right? Like you could do it perfectly, and sometimes it's not just gonna be the wrong answer sometimes. And so, like, that's a shift in thought of like, okay, how do we get people to think about like, okay, hey, how do you design a system that where 1 + 1 doesn't always equal 2, and what do you do? All I think a lot of times now is like there's a set of people with ML AI backgrounds who are really good because they've been trained in a more stochastic evaluation type stuff, and so like that set oftentimes is like just the process and culture side. Oftentimes that stuff now gets routed to a subset of folks. I do wonder in the future if that'll become just more part of the training for everyone is like, okay, hey, yeah, you got to learn the deterministic stuff really well and do a good job there. But does everyone need to get a lot better at evaluating and understanding and just like thinking about problems in that way too?
Got it. Now, in Relate IQ, especially, you had an email system that was looking at the rest of the data and giving the output, right? Now, there are cases where these kind of systems learnings help you build the next level of systems, and there are cases where the next level system really want you to have a reliable. In this case, for example, when you bill a client, you don't want to really show or have a ifiness there because now you're talking about dollars, right? How do you manage that this transition does happen to the end product, right? There is a system behind it. It is doing a lot of iffy stuff, but there is another system that's going to take care of everything. And now you're getting a deterministic output because you have to rely on the outcome, right? Could be agents in play using an LLM. LLM is not deterministic, but your agents are, right? So what do you do? What is your suggestion?
I think it's figuring out one like what needs to be deterministic, where you want to apply these probabilistic tools that are most effective, and then where do you put in humans as well, right?
So in between, there'll be humans to really fix some of these
Yeah,
problems,
yeah,
or there could be a system.
exactly, exactly, right? Because like also part of it too is like thinking about whatever product you're building, like what are you replacing, right? What workflow, what happened, what used to happen or didn't happen before, right? Because like actually in the Relay queue example, we crawled a bunch of emails and then we did analysis on it. What used to happen before, people didn't do that, honestly. Like, so they just didn't have information, and we're providing more information, is what it came down to. At Laurel, people do timesheets, right? That's how they get paid. So they did timesheets. That was that is a very time consuming imperfect process, right? And so like for us then it's like, okay, cool. We have a deterministic thing to go pull your activities where there's non-deterministic thing that will construct some of those time entries for you. And then like actually, like, let's tag you in as a user to be like, does this make sense, right? Like, like it is. We're generally not like completely automating and sending those bills out. Like that's a step too far, at least right now. And so like this is a step right now. It's like, okay, this is where we're tagging the user. We'll make it a lot easier for them, so they'll save like, I don't know, 90% plus time in constructing these time sheets. But it's actually okay for them to tag it. Like they're actually quite excited to do this, right? And so like that's actually part of it. Is like you don't have to automate everything, right? Like that's not necessarily the goal for all these things, right? It's like, okay, are you actually helping the thing happen better, faster, all that stuff? Um, and it's okay to tag in the user at different points. Sometimes you don't have to because it's like, hey, this is actually one safe to do and new stuff that's just net additive. But I think that's a big part of it. And this goes back to like understanding the abstractions of where you're deterministic, where you're probabilistic, and this like close this tie to design, like product design of like if they feel like you're giving them a win and you're really helping them, then like great, like let's do that.
In fact, although this was not part of the podcast agenda, I think I'm a customer of your product indirectly, right? I use a law firm that uses your product. And I have seen, and I was always thinking, yes, I do negotiate with them big time, right? But I've seen that the accuracy of that bill is very, very close to what exactly happened. I always used to think that how come they are really tracking everything this well? So yeah, so if you're thinking of debate or debating of using Laurel, yeah, I have used it indirectly. I didn't know that. I was using it until we had this conversation. Perfect. Now, what does the deterministic layer or separating this layer let you do? Right, these two layers let you do that you cannot do without separating those two.
I think a lot of it, maybe I'm too old or something, but I do feel like a lot of things end up being a very human thing, right?
Uh-huh.
And so by having those layers separated and it being clarity, it really just allows you to build more, right? This goes back to what we were saying before about abstractions and understanding that. And so like if you if you have clear understanding of those different layers, the team can go do more interesting things, right? If that makes sense, right? Then like if it's all muddled together, it's very hard for the team to be like, oh, this is how I should build this new thing. I got to think about like, oh, how is this going to be treated? Like it's very freeing, right? To have that right structure. Just like not just this, anything, right? Anytime you have good structure and good that, like it's it's not about constraints actually. It's that kind of definition allows you to be more free, right? Because you don't have to be like, I have to understand every part of the system deeply to do anything. I can be like, okay, cool. My job here is to very deterministically get this information that someone else will use. Like that's my job. Great. I can do more of that. I can add more data sources and do whatever, right? Or it can be like, hey, my job here is to take this deterministic data and come up with something new and exciting, and it can be probabilistic, and that's okay, right? And that the freeing element of that is so huge to be able to build new interesting things and try things, right? And I think like with like AI code development now, right, and these like feature development, that you actually really want that. You want to be able to have the people who have insights on what the customer wants and are spending time building product to be able to think about that mostly rather than like, okay, hey, if I touch this, am I gonna move move the cheese for like 15 other different features, and it's gonna be very difficult, right? So like I think that's really the real reason for it is like it allows you to move quicker, it allows it to be more maintainable, allows you to go debug things, et cetera, and like that cleanliness goes a long way.
In short, one layer is not dragging the other layer or slowing the other layer down.
Yeah. Yeah, yeah.
Got it. Now, in this conversation, we spent a lot of time talking about one layer being deterministic and the other layer being non-deterministic. Now, does the same architecture hold true when the one layer gets a lot more closer to being determined? I don't expect that layer to be fully deterministic, but closer to deterministic. Does the same architecture hold true?
I think so, in the sense that, like, you still kinda wanna know which ones are which, right? And so, like, I think I think the extreme levels, maybe not. Maybe, like, it doesn't matter as much. But I do think at some level it's quite useful because, like, they're just um, even as you push how predictable, et cetera, something is, then, like, it's still useful to be able to separate those out, right? Because like, I think even if it gets to be like well, actually, I think there's a couple things. If it's super predictable, depending on what system you're using, like, why don't you just make it completely deterministic? Like, what's the gap to get there, right? So I think that there's a question that rises there. But then two, if that's not possible and that's not a thing, is like the types of techniques and the types of expertise you would think about to go and solve the different buckets are there. They're still different, and so I think having the separation, I think, still leads to the cleanliness and easier maintenance and easier moving forward.
Scalability.
Yeah, exactly. Just from
Got
a humans working with it or anybody working with it standpoint.
got it. From a technology standpoint, right? So choice of technology standpoint,
Yeah.
like just going deeper into that for eng leaders, hands-on keyboard leaders. Is there an example of tech that you would never use in one of the layers, and is there an example that you would never use in one of the layers?
I think my thoughts on tech to apply, and like we use all the kind of probably what you expect streaming processing stuff for a lot of this stuff. We were either SQS, moving to Kafka queues, and looking at Apache Flink for some of this stuff, and using Airflow and for like managing DAGs, all that kind of stuff that you would expect.
Airflow and Astronomer, or
Yeah, on Astronomer. Yeah, yeah. We're using a lot of those things you would expect, but actually, I think with this new world of AI code development, I think to me a lot of it is like, all right, hey, what are the standard things you should be picking? Because like CodeGen is pretty good the more standard you pick, right? And so I think that's actually really big. And then the other part, and this actually goes back to the deterministic and probabilistic side, is like how can you provide as much deterministic stuff in your tech stack choices as possible, right? Like the really simple example is like, can you get really good at static typing, right? Because like the more the more you have deterministic failures going back to your AI code gen stuff, the better, right? It'll be better. And so like I think so where you can get static typing, the better. And so I think that to me is actually the biggest thing right now in terms of tech choices for tech stack stuff is like what can you do that really gives you more and more structure so that those LLMs who are writing code now can do it better and higher quality, and like your humans that are in the loop on that have a smaller, like a more focused job they can do on it as well. I saw some talk about like people rewriting their stuff in Rust for a bunch of different reasons. I've joked internally like we should go all Haskell, right? Like just all go all the way, but probably not that. But yeah, if that ends up being seems to be the big choice about tech stack stuff now.
so Jason, about now the hot topic here, right? How do you increase dev productivity with AI? Right? Everybody now says, yeah, just you have Claude.
Yep.
Why don't you go write things in 1 minute or 1 hour that you could do for 1 year?
It's wild how much things have changed, right? Like even just a year ago, everyone at our company at least was like using Cursor and using that, etc. Now everyone's using Claude, agents, whatever. We're using all kinds of combination of things to do this now. One, very few people are handwriting any code now, which is a fascinating thing. But I think, and I assume a lot of people are seeing this, is like the bottleneck no longer is writing code, right? Like we can write code, and like why can't you do things super fast? But like at the end of the day, our job isn't to write code, right? It's to get a functioning product out there in production, right? And so like what we've seen is like there's more and more bottleneck on the rest of the process, right? There's especially things like code reviews and qualities and et cetera. And we're seeing that, right? And like we're using a bunch of tools to help us with automated code reviews, but like they're just not as good as the CodeGen stuff, right? Like we use Devin, which is the cognition thing, to do some code review. We've actually hooked up some of our own stuff to like give us some guidance on what to do as well. So we've used a couple of different things to help. It's not like we're not like, oh, we can hands off and not do human reviews. And so we've done a few things, but not quite there. I actually have a hypothesis of like just how the software development lifecycle has to change a bit. Like the whole PR code review, et cetera, system is weird. I can give my personal hot take that's probably not that hot is I've always thought human code reviews were kind of shit. And in the sense that like they're fine and they're good and then like you should do them and historically you should do them. But they weren't like the best at catching things, right? Like what it came down is like you kind of had to trust the person who was writing it. And actually a big value of it is one, knowledge share. A second person kind of sees the code and gets introduced to the code. But two is the social pressure. It's actually the social pressure of like, I have to go show someone else this is my work. And so I'm going to make sure it's pretty good before I go and do that, right? But it wasn't actually that good at catching quality. It wasn't actually that good at knowledge sharing. It had serious limits, right? We had all these other things that actually did it. But now when you're doing so much code gen, and actually more and more of the job is code review, actually, that weakness is showing up, right? And like the social pressures aren't the same because suddenly like people are like, oh, the agent did this, and you don't feel as like this is my baby that has to be good before someone else looks at it, right?
Which is in some way good.
Yeah. And so like I think that part is where we're feeling that breakdown is like, okay, hey, that system wasn't ever good, and now it's like amplified to 100, and so it's like really problematic. And so like I do wonder like, hey, what else can we change to make that more doable, right? How do we make sure that everyone has a deeper understanding of the code so that when we go release it, the people actually get it? The analogy I've been kind of giving is it's almost like we're all working in a legacy code base all the time in the sense that like it kind of makes sense, but like the human who wrote it, you don't necessarily know, and you don't have the deep intuition that you might have when you hand wrote the whole thing, right? And so I think that's part of it. Hey, what do we need to do about how we do that whole process? So we can code gen real fast now, but like, how do we make sure that the person who owns it like deeply understands it to have the right intuition, or otherwise we have the intuition somewhere, and have enough of that quality check so that we have confidence in what's going out. I think a lot of that is like the deterministic testing and et cetera that we do to improve that. But I think there's just a few more steps in there that are they're really fascinating to think about, right? Is what that future looks like. And then of course there's other parts of like, should we do it, right? Like so, like part of what we've done with our development tools is we've actually allowed non-engineers to effectively vibe some features, right? Like we give them a coding agent and give them the right context, et cetera. There's engineers and others who obviously review this stuff before it goes out. But part of that is actually like, hey, if you're a CSM, one of the challenges there is you don't always have the right context of like, should we do this, right?
Yeah.
You're like, hey, my customer's asking for this. We should do this.
Does it even make
It
sense?
doesn't make sense. It may make sense for that one, but it may not make sense for everyone,
Yeah.
right? And so I think that that's the other part too, is like, and actually for when we have
Yes.
like people outside of the EPD doing this, we actually have not just an engineer look at it, we have a PM be like, should we do this? From a
Product
product
manager.
perspective,
Yeah.
like it's effectively a
Product
PM
decision
PR
making
review
else. Yes.
that happens even. And so like that's the other part of it too, is like all the other decision making parts that go into this, besides the code writing. My code writing is way faster now, but this all the other stuff is still there.
Yeah. The product managers do write vibe code and developers review. Okay. I think I have a slightly different, not different, similar view, but I think a lot more easier. Generally, I see agents doing something and humans reviewing it. Right. I think if we can make it a three-step process, like agent doing something, human reviewing it, and then agents again to taking a look at it. Right. I'll tell you why I believe that is a little faster. At least we have tried a few things. So when humans review it, you get a lot more context about that review. Right. So yes, these are the things that they don't like. Now when agent goes in, it has a lot more
Yep.
context. It
Yep.
might find a few more things.
Yep.
The second good thing is generally for all of us, perfection is a problem. In fact, I know that there are a lot of people thinking perfection is awesome. In my mind, it's a problem, right? And this helps you go faster in reviews because you know that there is someone else. There is one more gate. And not that you'll be responsible when reviewing, but when you do your review, you at least have the peace of mind saying that, you know what, it's not
There's
going
another step.
there.
Yeah.
There is one more step.
Yep.
So that makes, in my mind, things a little better. And we are trying that here.
Yeah. I actually think this is like one of my questions is like, is it almost should be more iterative in partnering? I think like one of the challenges of having a human review at the end is like, oh, there's a big thing that I gotta like try to understand, figure out. Like how much of it should be more interactive as the agent is going doing stuff and like a human reviewing that and giving back feedback. And there's just almost like several loops in that way, right? And more. And like I think what happens is actually people do that in different ways, either because in your PR system you review and you go back to agent and then you look at it again, or when you go work with the coding agent in the beginning with you do a plan mode to be like, let's go back and forth with the thing, etc. But to me, it still feels like it's missing something, right? It's like there's still something there that it should be more collaborative, honestly, is the way. Because like you said, it's like the context is like, oh, hey, actually, I care about this, or I forgot to tell you this thing that's super important. And like, how do you get that back and forth to make sure we build all of that into it? I think that ends up feels like the thing that's missing. And like some of our tools now were built before that. And so like, okay, what needs to change and how do we think about that?
I think testing is also one area where people are using it heavily, and we use it at least. Uh, I believe most of these testing, unit testing, I know there is a philosophy that's a fun thing to do, but I think most developers still think it is a responsibility than like a fascinating thing to do next, right? And this gets
Yeah.
that done.
Just close it down. Yeah, yeah.
Yeah.
That's a really interesting thing. Yeah, it's like the ability to write those kind of tests is obviously way easier. Obviously, you have to be careful because sometimes AI will cheat the test. Everyone knows AI will write fake tests. You got to be careful about that too. But then, yeah, like what other things can you do? I think an interesting thing about this is you can create so many automated tests and end-to-end tests. And like historically, at times you didn't want to do that because your whole build system would slow down, right? If you have to run an umpteen amount of tests. But actually, I think this is the exciting bit too. Is like, hey, can you one run a bunch of tests? That's a good thing. But then can you actually use AI or whatever to be smart about which ones you run in which cases, right? And I think there's like those kinds of opportunities that I think exist, like that default intuition as a software leader being like, all right, you want to write automated tests, but you don't want too many, so they don't like block things. They don't want to be too fragile, and so that heuristic should change. Actually, you should write a ton of tests, but now can you apply this to like be smart about which ones run so that you have to reduce your risk at the best without creating slowness in your pipeline. And I just feel like there's a lot of those kinds of shifts, like this other one of like iteration quickly with it's fascinating those kinds of changes that might come.
Yeah, I somehow feel that there is going to be test incidents, like production incidents, because now there are a lot of tests that people don't even understand what exactly happened. Now, if you're really trying to look at a test that failed, which you did not even write, it's going to be another day effort. Figure out what went wrong, right?
Yeah,
It's
yeah,
almost like a production incident now.
yeah.
Okay, I see. Now, AI in a company is not just dev, right? So where all, at least in your Laurel, this company, Jason, you are applying AI to. It's only in dev or mostly in dev?
Devs are obviously very heavily in AI for a lot of things we said. Whole companies using AI, very AI forward. Where everyone has Claude we're sharing Claude skills for everyone. People vibe coding apps and building stuff all over the place. Very active discussion I'm having even this week. Claude Plus, there's a set of folks who are building and just like using Claude Code or whatever to actually build apps to. So it's not just through like a local Claude instance or anything like that. And so that one's a fascinating one too, because like when people are using AI for their own tools for their own day to day, that's actually pretty manageable in the sense like it's very assistive to their work. So it's their job to manage that work. The ones where you have non-engineers effectively vibe coding apps, internal tools is a very fascinating one because like then you have this interesting challenge of like how do you manage some of the risk, right? It's like, how do you manage the risk of like they mishandle data in a way that we need to worry about? Is there security stuff in terms of access control, et cetera? And then like, is it correct, right? And so like, I think a lot of that is like that's what we're working through. And like, I think the first two buckets, a lot of it is like, all right, we need to figure out. Honestly, the technical team is like, how do we prevent people from shooting themselves in the foot because they don't understand the security things, they don't understand data. So we got to give them a playground to work with that they can only do so much bad things, right? Limit the risk. And then some of the other ones is like, hey, it's your job, right? You can vibe a tool. It's your job to make sure the tool works, right? Because effectively, if you didn't have the tool, you'd be doing it by hand, and so it's your job to make sure it works. And so, like, getting really good about okay, what can be done, what can we be people for freed up to do, um, is very fascinating. I also do think there's going to be continued more training in almost everyone and understanding software. Not even the vibe coded part, just like understanding software so that you can understand where if you do vibe code an app or whatever, where you might misstep and create yourself a problem, right? Versus not, right? And like, um, actually, one example is like, we're trying to describe to folks is like, hey, what different kinds of apps and like this is the different things we need to do. And someone's like, oh, I have a static app and like it doesn't need any state or whatever. And then immediately it was like, oh, they obviously did need state and need a database. And that's fine, they didn't understand, but that's almost like the training up we'll need everyone to do is to figure out, okay, hey, what are the right ways to think about it? So therefore we can provide you the right tools and guardrails and whatever so you can do it in a way that's safe and will work well.
I have an example. So one of my engineers, he mentioned he was going on vacation and his AC had an issue and he didn't have time to fix. And when he's back, he wanted it to be fixed. So he built a few agents, and one agent asked around and said, "You know what? Who can do this?" They sent the code. This guy said, started negotiating. So he got the best code. He looked at the reviews, made sure that everything's good. In fact, he got it fixed. So it works in some cases. Yeah, yeah. You get productivity outside of work too. So that's a good thing. Yeah, we are also heavily into Claude. I think that's generally so.
There's obviously the question of what's going to happen with how you do development, but I'm very curious about like how all functions, how all people end up using this and what they what they build, what they just use out of the box. Like it's fascinating.
Yeah, I think it's probably a lot of unlearning to do than learning. We used to be passionate about algorithms and quick ways of doing things, and I think those are gone. I think this elite 10 lines of code,
Oh, sure.
pride in that is done. It's gone.
Yeah.
Right. So that developer community is not. I don't know if it's even required anymore. It probably is more idea to really getting to something that's useful for the customers.
I don't know. Years ago, I was like, oh, you know what? The future will be everyone needs to know some software and another function, another expertise. Cause like it's gonna be like, how can we apply computers to that thing? Now it's I think effectively that much faster. It's like you need to be able to understand what the customer thing because everyone can effectively apply software to it. I do think some of those algorithms of specific things will still exist, but in much smaller slices, right, where it matters. For the vast majority, it'll be connecting it to the problem. The other part of it is it feels like it's going to be less about the algorithms and getting into details. It's going to be much more about having the right intuition about how software works. Like, we're just talking at the very beginning about, like, um, data quality, right? Like, good data in means that, like, everyone needs to know that, right? That has to be everybody needs to, like, think about that. And then I think everybody will have to think about the structure of data and et cetera. Like, even people who don't think about that at all now, like, to do your job well in the future, I think you'll have to have that kind of intuition about software architecture and things, because, like, that will allow you best to apply software and LLMs, et cetera, to the problem, right? And so you kinda have to have both, like, "Hey, what does the customer really need?" And then, like, "How can I think about that problem with that kind of intuition so I can be most effective?" And, like, you kind of vibe code it without it, but you'll be better and need less help if you get it, right? Like, you don't have to be a database expert by any means, but you should be like, "Oh, hey, these are my sources of data. This is how I should think about them. And so therefore, if I had that, this is what I would do." So it's, like, almost that kinda logical thinking and that structured thinking, even if you don't care or know how the algorithms themselves work.
Thank you, Jason, for sharing how to build a system with those two distinct layers and your learnings and how all of us can learn from it and not make it again.
Thank you for having me on, Suresh. This was a lot of fun. I appreciate it.